day 4, BQN, Ray Programming Language. Day 3 was awesome. Let's see what day 4 has in store. I still have not solved day 1, part 2, but maybe someday. Uh, you ride down the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there's even a massive printer in the corner to handle really big print jobs. Okay, I'm not going to read this. If you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. The rolls of paper are arranged in a large grid. The elves have even a helpful diagram, your puzzle input, indicating where everything is located. So each one of these is a roll of paper. This feels like pathfinding, and I'm not looking forward to it. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in 8 adjacent positions. If you can figure out which rolls of paper the forklifts can access, then they'll spend less time looking and more time breaking down the walls of the cafeteria. Fewer than 4 rolls. So I think it has to have 4 free adjacents, like or any of them, I guess. So this does not have a free space. Wait, that can be accessed by a forklift marked with 4. Oh, sorry. Fewer than 4 rolls of paper in 8 adjacent positions. So this guy only has 3 adjacents. This guy has 3 adjacents. This guy, for example, I'm just cross-referencing with this, but it looks like 1, 2, 3, 4, fewer than 4, so 3 or less. Okay, good. Okay, how many rolls? Okay, well, there's a way to do this, sort of. I won't be able to do it tonight. This is it's 12:05. 5 minutes past the release date of day 4. Let's figure it out. Let's try. So the what do we got? It'll be some sort of like Xmas thing where we have to like diff against the neighbors, obviously. But anyway, so let's show lines, right? Because this is our data. We can just show each lines. I could actually just do this, right? This will no. This is merge. Oh, it's a close merge. Here you go. So this is because well, I'm installing. But if I get rid of this, actually I don't need this. I can do this. Perfect. So if I hold the phone. How come I'm getting? Oh, I forgot to do the what's the word? Line wrapping. I gotta put this into my there you go. Okay. Oh, this also prints a new line also. Interesting. Anyway, part 1. Sorry. So part 1 is just a list of strings that are all the same size. So because they're all the same size, I can merge them together to make a matrix. What? That's the show? It doesn't like show? Hold on. What's going on? Oh, our log here. Oh, wow. This is an old script. Okay. So, again, this is a list of lists. I merge them all together, and now it's like a matrix. So I don't know. I don't know how to put this, but it's like stacked on top of each other instead of linear. Uh, so instead of like one, instead of this being the second element on the first dimension, it's the second element on the second dimension. I don't know how to put it, but you can imagine what this is. Hopefully, I bet you if I could explain it better, I would be able to use them better. But anyway, yeah. So I can, if I want to, here I'll just return 1, 2, 3, just make this easy, and or infinity, just to keep this 9. What is it? 8? There it is, 8. I can rotate it, and it'll be the same thing but like different. And I can also transpose it, which is the same thing but on its side, maybe side. Come on, there it is, maybe something like this. I don't know if that actually did anything. This is where my my BQN foo fades out. That changed nothing. Excellent. Uh, that reverses it back to what it used to be, right? No, I don't know what I'm doing. The point is, transpose is supposed to supposed to fix this somehow. Oh, it's the same. Is this square? Here I could actually just do shape of this. That'll tell me that could be why it doesn't look like it's changing because the width. No, that doesn't make sense. M. Yeah, okay, it is. It is square. It just the I don't remember how to. This is a square. It just looks rectangular because the each cell or whatever is a rectangle. Good. Good. Uh, so the reason so that I might have been right the whole time. So this is a rotation probably reversed probably, and this is on the other angle or something. And then this is also so all four of these are rotations, I guess is what I'm trying to say. Twisting them all about. There's some way to like compare them or something, but I don't know how. I can shift them all over, I guess, by one. So I could do this. So here, if I show 3 by 3 range of 9, is this how this works? 10. There you go. All right. Okay. This is the range of 9, so it's 9 digits in a row, and then I reshape it to 3 by 3 matrix. So this is almost the same data, almost. It just reshaped differently. So one-dimensional list. This is a two-dimensional list of lists or something, but not exactly that because otherwise it would be nested. So just appreciate that, I guess. So what I'm saying is I have a way to rotate it. So I can do this to rotate on its corner. So see how 0, 1, 2 is going horizontally, and then I can also transpose reverse it. So now 0, 1, 2, the horizontal line is now on the bottom horizontal line, and I can combine them with this or something. That did do something, but I can't tell what it did. Oh, is it order of operations or something? You have to like transpose it after you rotate it. I don't know. Uh, what is this actually? If I show this too, right? We have our original, and this is rotated 90 degrees. Is that how this works? Yeah. Okay. Go. There you go. Perfect. This is rotated 90 degrees. So if I rotate another 90 degrees, it would do the same thing again, if I'm not mistaken. Yeah. Okay. There you go. Perfect. Almost looked like an idiot for a second. We want to show after everyone. Actually, sorry, I should have remembered. So 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. And I think uh, if we're using if we're using ats and spaces or dots, as spaces, I could basically put in shift in like a dummy value to every row here, and that would account for checking the guys on the left side here. Like this gentleman here in top left corner has no left or top neighbor. So by shifting a null and then like not comparing against that or something, or shifting in a blank space, I should say, would be equivalent of him because that's satisfactory for part one. Hopefully that makes sense. So what I'm going to do is I'm going to where's my code? Here it is. I'm going to okay, let's get rid of this for now. And I'm going to say it's like this or something, and I shift in dot or something. And it's not going to like that. There's a reason. There's a reason how does this work. Shift after. Remove the last element. Oh, I don't want to. Okay, I don't want to. I don't want to shift over everything. I want to add one to it. Can I do this? Yeah, perfect. Look at that. Neat. Uh, so I want to do this to every single one. Basically, I want to rotate again and show it. You know what I mean? Because I don't want to just rotate this guy again. Because I'll have the dots at the bottom of the screen now, or top, or whatever. Why? Oh, because it's on the left now, right? 90 degrees is towards the top. But I don't actually. Yeah, this is a good example of how the rotations work. You can really tell where it goes. But yeah, so I don't want to do that. So I want to, I want to build up a list of these functions first before I get to the joining business. Sorry, I should say also, this is each cells. Sorry, so this runs a function on every one of the cells of the list. Cells are sort of like the first lists or first element of a thing. So the matrix, the first cell is the first row, whereas the first cell of a flat list is the first element or something. Join just joins things together. Join two. You see, join these together gives you that, and then I just joined the period, the single character period, and that puts it there. If I put it into a string, uh, it'll mess up, I guess, because this is a one element list. I don't know what that is complaining about, but let's not worry about that for now. So, I want to. Oh, I remember this from someone else's answer for the Xmas thing. I want this function to be called repeat once, let's say, and this should be the same output, right? And if this is another rotation, yeah, and another rotation, and then this is back to square one. Good. Now, if I want to, and this, sorry, and this would be the same as well. Still, no, it wouldn't actually. But so this is repeat, by the way. This is how do I? It just whatever value this returns, it calls this number. Like I said, calls this one that many times, right? So, for example, here it's adding 1 to 1. Oh, there it is. 4. Jeez. Yeah, adding 4 to 1 times. Here's adding uh 4 to 1 2 times, and 4 to 1 3 times. Okay, easy. So I want to track. Oh, okay, then I'll just copy the result. 5, is that right? Neat. Yeah, that's the docs show you there, right? If you just pass it a list of numbers, it'll take one single list or value, which we did here with our first input, and then gives you back the whatever's of inputs. Nice. Okay, so then now, uh, from this bad boy, actually, I can just combine more garbage here. So I can say, period, join each. Right. This is the same thing. Oh, no, no. Okay. Yeah. Okay. I didn't want to join it here. I want to put it here on each one of these. Sorry. There's probably a better way of writing this. Yeah. There you go. So for each, so remember, because here, when this value comes in, we have a list of matrices. I want to go through each element. Well, here, what I'll show you. Oh, I don't know how to explain it really, but each goes through the elements, and this goes through cells. And major cells are different than elements. So personally, I just mix and match until it doesn't throw an error anymore. But each goes down as low as it can almost. Whereas cell just gets the first thing it gets back and doesn't complain. So if I go back to, if I get rid of my, if I change this to actually just doing, I'll keep this actually, but I do uh, lines, right? This should be the similar thing. And we also, do we want a fifth one? Because this is it shifted right. Uh, uh, is it? Okay, this is perfect. We're gonna go back to here already. I don't want to rotate, is the thing. Yeah, okay. I don't want to rotate. Yes, I do. Oh, okay. Then, if I how do I unrotate something? Is it as simple as basically I want to when I'm done rotating, uh I want to have 0, 1, and 2 be at the top, and then the dots on whatever side it was supposed to. It's gonna complain probably. Well, whatever. Let's see. Uh, hopefully that makes sense. Like I want these dots to show up where they're supposed to be, or something. Hold on, now I'm getting lost in the sauce. I want to compare the rotations to something because comparing, like for example, 6 to the original 0 doesn't mean anything because they're not even touching. Hmm. Maybe I should just add dots to everything around this, like all the white space around, and then just deal with shifting things over. Right. Okay. So the reason I'm rotating is because I wanted to add a blank space. Oh, this is tricky. There's got to be a better answer. But yeah, I do want to rotate these back into place and then compare them with the original or something. So let's just do it in the opposite order. Let's just transpose it back and then rotate each one. Maybe this maybe. Totally guessing. That was not it, by the way. Uh, here. No. I might be able to do this though if I simply undo this. No, that was just a total guess here. Right? What? Equals the little equals is undo. Just so we're clear, right? Yeah, perfect. Inverse. Does it change the output at all? It did sorta. Wait, this sort of looks right almost. No, it doesn't. Right, because I don't want to undo this. Oh, no way. This won't work, right? No. Yeah, this is too many elements. I was hoping that this would actually if I did this now. This would do something, but it's not. It's because it's doing like there's too many cells here, so it's got all these rotations back in. But I don't want that. I want each index because okay, so here if I show the length of this, there's 4, right? There's 4 elements in this. So I want its index to be tied to this and then rotate that many times. So can I actually do something like okay, so if I go back here and I do if I merge this again, sorry, what happens? It just turns them all into this is now a matrix of matrices. So a 3-dimensional array. So 2-dimensional matrix or 1-dimensional list. But I want to go through here and I want to say, hey, tell me your index. And I think I learned last time that I could do this, right? No. This is where I'm talking about where I have a uh selfie? No, no, no. I want to for every element. No, no. Classifies elements, right? And then tell me join. I'm trying to think here. This is giving me all the indices of all the objects, right? And I want to undo that many times. Like this number applies to this matrix only. But how do I do that? I can do this maybe, and then like pairwise it or something. Pairwise it. Oh, I only want to do this maybe or something like that. There you go. Okay. So this is in pairing or coupling, pairing the two things together in a two element list. So this is now a two element list of the number and then the matrix here. Good. And I'm gonna just swap this to put the number on the right side because that'll be easier for when I do the repeat or whatever. Oh. Oh, okay, so hold on, if I get rid of the repeat for now. See how this is 0, 1, 2? I really want this to be, oh man. I want this number. In order to undo this, I have to repeat this, rotate this 3 more times, 2 more times, 1 more time to get back to the original rotation. So I need to, I can calculate the length. I can just punch in 4 for the record, but I know that I have all the objects here. I can just calculate the length and pass that to the result of this. Hold on, I'll write it out obviously, and then we'll see see where we're at after. So here is our the current answer, right? And so we want this. Now we want to do after we pair. No. Before we pair, we want to check the length of x, and then subtract 1 from it. Hold on. X being this guy, sorry, not KDB's x, minus that number, actually. Okay. I gotta do negative. Right? So this is. There we go. I think that's right, right? Is that correct? Oh. I think that's the right number because it was 0, 1, 2, 3, and now this is 4 minus 0, 4 minus 1, 4 minus 2, minus 3. Okay, so now I do the same thing again, where I actually just rotate the left number, and I fold, or not fold. Fold. Damn it! What are we dealing with here? I'll get rid of this function, inline function, in a minute, but for now, what is G? G is this thing probably. Oh, no. For every this, then I do this, right? That maybe worked? Maybe? If I put a show here after, what happens? Yeah, okay. That gives you a number. I just this isn't rotated, so what is going on? Okay, hold on. Let's we're not done. This is still illegible, but that's fine. So now we take this number. Okay, rotate cannot be a unit. That's fine. Why can't rotate be a reverse, not rotate? Is it the same number? Hold on. Reverse and rotate, yeah, it's the same name. This is monadic, 1 argument. This is dyadic, 2 arguments. Monad, dyad. Unary, binary. Okay, what is chain surrounding this to this? Oops, and then we go here, and then we show. We don't need this anymore. We can show what the answer is. 4. Why is it 4? Oh, because that is the opposite character. Okay, so we don't need to show anymore. We also don't need this anymore. Oh, now, well, no, that's fine. So the fold of F must be a list. So when I find X here and I say show it, this is not going to be an array? Oh, it is. Oh. Oh, well, screw you, buddy. No, we're still we're back to where we were. Surely this is some advanced repetition here. What? Before we show this again, let's exit, okay? We'll just simplify our lives. That's not good. So I don't want this. I want to just get the what I said I wanted, which is the right one. I want to fold it. So what's the issue here? So let's show what you are. But there's no, yeah, why is there a paired matrix here but not here? If I get rid of this show, yeah, that output doesn't change, it's still there. So it's like the second time. Oh, how do I do this? Okay, so the reason what's happening is the first loop is working as I intended, right? Where it's got the numbers. But I'm actually, when I return this, so I on the first call I have this pair, right? Again, this single, the atom, the number here, and then the matrix next to it. I only get the right argument, which is the matrix. Then I transit and rotate it, which gives me the rotated version this time. But now on the second repetition, there's no more number. And I can't I can't undo this because it won't return the same shape, I think. Oh, I don't know if that worked or not, but let's see. Yeah, presumably because the shape is different. I don't know enough about that for sure. Well, actually, is that what the problem is? If I again go in here, go show, just to see if we're actually getting more prints here. We are. Yeah, but again, I assume because it's the different shape or something, it's going to complain. Because it expects to get back a 3 or 4 column 3 row thing, but it's going to get back the opposite, a 3 column 4 row scenario. So that won't work. So instead, I'm looking at this thing and I'm thinking, hey, how do you repeat this? How do you how do I pull out the oh, by being a shitter? Watch. I think. I think that's exactly what it is. Just by using names. So uh N for the number, or I for the number, and then M for the matrix, okay? There we go. And then a new line. And then this is for, you know who you are, who's complaining I had too many line breaks. If I do this and I go here and I change this to, oops, yeah, oh, come on. Just the, doesn't like the percentage thing. But anyway, look at that. And then this is not X anymore. This is now M. And now, you son of a gun. I trusted you. Yeah, M is what I expect. And I is presumably what I expect. I is 4, yeah. So, what's the issue here? show. Doesn't, oh, this is not repeat. There you go. I was way too lost in the sauce here. This is going further back. Yeah, here. M. Okay. Now we're getting further, which is good. And oh, that's good. Why is the output? It just worked? Yeah, okay, it just worked. Great. Okay, you know what? Let's simplify this even further. S M equals this. Yeah, same thing. Little pattern matching. It's not only in functional languages. I guess BQN is functional, but it's fine. So this is the same thing as I unpacked. So you see here before, where I was unpacking X into this argument here, where I break it. I take the first and second element, call them I and M. Well, this is just doing the same thing, where the argument to this is called I and M, and then do that here. But again, this is not at all part of the problem solving. But this 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 has to be able to be something like this. Like I had it. This and then whatever X is. Uh left of X. And this is X here. I guess it's implied to be that, right? Yeah, so that's fine. So the whole problem is I just didn't pre-apply it. Yeah, okay. Let's go back to implicit code here and just deal with this as it is. So just be clear, it's the same as before. This thing now returns a function. So that's actually the same as right. And I need the X here to be named as far as I'm aware right now to get the argument. Oops, to get the argument list. What a world. Okay, so oh, we lost our dots. Friggin' wonderful. Where's our dots, man? Where's our dots? Do we have them here? We have them here. All my laughter. I was naive. I thought, thought I was someone else. What? So, oh, what's going on? Oh, I jaded, I guess. Uh, at this point, the things are gone. So, what is this? Why is it not? Is it like spinning forever? What's the deal here? Yeah, what is going on? What is happening? Oh, I have an exit right here. Son of a gun. Uh, that is awkward. Is all my logic about? It is great, wonderful. So it doesn't return a function at all, or if it does, I never called it or something. I don't know. Who knows? So really, why? How this? I don't know. It's fine. So that's there. So now we're back to here being well, sort of rotated. Uh, can I do -1 again? Does that give us rotations or +1? I'm just guessing here. Okay, no. I thought I had this rotation sorted out with all my magic here. Uh, but I don't because this is equivalent to this. Sort of. Sort of. Sort of. No, I did it. Son of a gun. This is it. I wasn't even looking at the right thing here. I was looking at where the dots were. But no, yeah, this is it. 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Good. Oh, it's 12:39. Oh my goodness. Okay. I'm just trying to think. This I'm still, if I want to merge these all together, I still have to have line that line of dots around them. And I don't think it's any clearer, but if I replace first do this, I can do this, I think this should turn them all into at symbols. Yeah. So like if I join these all together, oh yeah, that's not only helpful, more helpful. If I have no, it is, hold on. I can repler every element in this. Okay, then I do this. Change this single quotes to double quotes. Son of a gun. Oh, then I do this. Nope. Because I want these all to be strings. That doesn't make sense. Yeah, why is this oh, because then I have hold on. That's fine. I'm not gonna yeah, okay, not gonna worry about that too much. Let's get out of this repr hole here. Let's go back to our ugly numbers. So if I have to merge these all back in together, they all be padded the same way or something. So I definitely need to have a replacement of all these numbers. What was I doing? The whole thing, the whole reason here that I want to do this was to replace. I want if this was an at symbol, I want to check if this one was fine and this one was fine. This one was fine. Hmm. I'm wondering if this is not necessarily where I want to be. Yeah, it's something to do with that game of life thing, where I shift everything over. But I don't want rotations in this case. Okay, hold on. I'm changing my plan. Hold on. If I go instead to not rotations, but like again, rotations being 0 1 2, 0 1 2, 0 1 2, and 0 1 2. If I go to something like just flipping it, because if I want to check your neighboring, yeah, you know what? Okay, let's go over. Where's my keyboard? It does it sometimes. Okay, if I want to just okay, let's go back to the past. So here, right? This is our values. If I have this thing, and I want to shift it over to the left, uh, every cell, every line shift over to the left, right? Actually, let's go to the left. Actually, not right. Like I said. So now if I show here, right, I can compare. I can compare the. God, this seems so uh, arbitrary. Yeah, this is. You see what I'm saying? All right. So this zeros by shifting everything over to the left, everything is now in its current place for the uh, right neighbor. Right. So okay, I'm gonna look at one. Actually, it'll be easier because there'll be neighbor on every side. No, I look at four because there'll be neighbor on every side. So if I look at four's right neighbor, it's actually five now, and it's the same index as four. So now, okay, again, I'm gonna do the the thing where I rotate it again. Uh, is that what I want to do? Hold on. If I do, okay, I'm just thinking now. If I do rotate it 9 degrees, shift over a thing and then unrotate it, that should be this. So like, for example, okay, I'm looking at this bottom one. Now if I well, I don't need to undo anything here. Oops. Come on, caps lock. Uh, I want to shift from the bottom, so I do have to rotate it once. So I'll rotate it. This right. Then I will unrotate it, which I assume is just this again. Yeah. See. Now I have five. No, no, that's not right. What is this? This is comparing it to his right. Four is here, and now compared to his right. But that's not what I was doing already, wasn't it? I shifted everything down, but I don't want that. That's still the right. What am I? I want to. Oops, I zoomed out there. Sorry about that. That's still it's right. Hmm. If I get rid of these guys, that's shifting to its right. And per cell. So I shifted over everything left here. No. For the original is still. Oh, I wasn't showing the freaking original anymore. Goodness gracious. Here. OG R log, okay? Uh uh rot one. And this is gonna oops. R log. Come on. R log. Uh post rot or unrot or something. So here is everything's flipped. And if I want to unrod it, I should actually unrod it. That'd be kind of cool. This is everything shifted to its left. Son of a gun. So, yeah, this is everything shifted over to, like, over to the right or something. And if I don't do this, this will just be everything shifted over from the right. Yeah, 5. Okay, good. So if I want to do the top now, I should have to turn each column. That's what I'm thinking. Is if I want to now uh, shift everything over, then I have to do here. Let's put 2's here so we're clear on what I'm dealing with. We'll call this the OG. And just keep OG here. And I want to... I do want to transpose it. 9 degrees. So rot 2. So if I'm... I don't think this is just... This is rotating another 90 degrees. But... Actually, it's just... What do you mean? Oh, yeah. Okay. Where's OG? OG is 7 below, right? So 7 is now moved up to the center. And then if I get rid of these guys, this is going to move it down. 1 is not compared. So this is what I'm talking about. I have all in an indirect way here. I have a way to compare all of them to each other or something. Does that make sense? And I'm just if I if I shift into them with blank spaces, then it's equivalent, and there's no like out of bounds checking. And I can now I want to figure out the under thing, the undo thing. So if I get rid of I want to get rid of this stuff because it's I can come up with it again after. But for now, I'll just add white space and not worry about it. So if I take in the OG, okay, and it's here, put OG back here, okay. Then I just to test out the undering thing, I want to drop dropped, okay, and I drop one character from every row or something. Is that how this works? For every row, sorry. Yeah, that worked. But then first, oh, but this doesn't do like this, right? What happened? This got every row. I return them all back and then drop the first one. I don't want this. I want every this. Oops, every this. No. Under what sort of transformation? I want to transform. Let's just rotate it. What is this doing? Yeah, I got rid of the last one, right? And this gets rid of the first one. Yeah. So then if I translate like this gets rid of the rightmost column, and this will get rid of the leftmost column. Nope. Oh, this would. This will get rid of the leftmost column. No. What is this doing? 0 1 2 turns into 1 2. Oh yeah, this is right. Yeah, yeah. Now the right column's gone, whereas this was the rightmost column's gone. Frick, there's no 0 anymore. This is gone, and then now this is the 2 goes away. Yeah. So that can be undered. Can undered be repeated the same way? The same way repeat can, but I don't think so. So, I so and the nothing here is to break this into like a composed function or something. It's sort of equivalent of doing this, which is just saying run this, then run this, then run this. And by default, because there's two functions next to each other, you can it automatically does that together. And then we put a nothing here or that red one to break the training or whatever. Um, so I want to do all 3 rotations. Did I cover this already? So so this is dropping the first column. This is dropping the last row. Sorry. So first row's gone. The 6th row is gone. The left row is gone. The right row is gone. So if I can have that one more time, F's okay is going to be this with what I just did, which was um uh, no, hold on, hold your horses. Rotate this, then this, then finally the last one, which was this. No, this. Nothing. I'm gonna feel so good when this is done. Okay, now this is F's. Okay, so I want to now take uh, X, which is a function, and call it on each of Fs. This should have several. What is this complaining about? What do you mean F doesn't exist? Show's not gonna work without. No, can't invert blocks. No, I want you to do what you just did, but yeah, this is a problem I have with BQN where it doesn't know enough to tell me about why this is breaking. But if OG is well, OG still OG, and then we want to do under X, and X is just the right argument as a function, but not F, right? Yeah, yeah. This is only for when it's a modifier. Can I show wrapper X? Does this work? Parentheses can't contain separators. Oh. Change running this to this. Oh, that's because X didn't exist. X was talking about lines here. That's why. That's why the ats were in the output a minute ago. Okay, sorry about that. Delete, find, semicolon. Perfect. Yeah. Okay, good. This is dropping the first column. Yeah, the 0 and 2 column altogether. This is dropping the last one. Dropping the right left column, and dropping the right column. Nice. Okay, cool. So if I now just shift the dot back in, right? This one, left, and then do this. Is that right? Scroll down. Shift must be the length of shift equals W. So the depth of W must be the depth of X, or let one less than X. Because I don't want to drop it, actually. I just want to shift it in, maybe. Change random quotes to this. Again, I don't understand what's going on. Because I'm trying to basically copy this. Oh, and then this? Yeah, okay. Okay. We're getting there. Are we? Or we're not getting there? Because this looks identical, actually. The right side, the right side. So what? Um, would be cool if it was LEJ if you could scroll it and then I could save it and it would still update instead of having to make me scroll down. These are all different functions, so they in my mind, they should all be doing the same thing. Here, I'll join it with the repr of x. Repr is just like you get a string representation of the function. This is dropping the left argument. This is not dropping the left argument. Oh, because I didn't drop it. I didn't drop it. I just shifted over. And because I'm not mirroring it over, no. Is it this? Do I have to put a here every time to match my other answer? Uh, here. Okay, so if I'm looking at 4, I want to check its left argument, which is this guy. Right argument is 5. Top argument is 1. Bottom argument is 7. Okay, so now we're in business. Okay, now we have the comparisons. Great. Great. Now what? Now the problem begins. I have all of the neighbors. No, no, this is only 4 adjacents. I need to check all the corners. Like, yeah, shifting left and right and stuff. I need to do all this, but rotating it again. I don't know how I can easily test that. Besides uh, doing all these again, whoops, all these again, but rotated before, like do the rotation once, and does that automatically handle it? Let's find out. Uh, this. Oh man, this is gonna be fun. I could definitely annotate this a little better, but for now, copying and pasting should be fine. Okay, now let's find out. Second level, okay, that's fine. So this was not fine. Have to do one for everyone here. I think I do. Let's complain about this one too once it clears out. Okay, so now we want to have in the middle 0, 2, 6, and 8 at one point after this one. So no, 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 no. Okay, none of these works. How come? What would this represent? I don't want to rotate 90 degrees. I want to rotate it 45 degrees. Again, this has got Xmas written all over it, which is one of the early ones from last year. Which I solved in a similar way to this. I can drop every element or whatever. I can drop every column by an increasing amount, and do diagonals or something. Is that it? I'm trying to think. Would that give me diagonals? Like, okay, if I drop this one by oh son of a gun, my buddy, it's my buddy just told me he's done his. I'm not done any of them. if I drop this by 1 or 0 and drop this by 1, that's 0 and 1, and I drop this by 2, that's 2. That doesn't help me for that tells me what's above here. It doesn't I need to get 0 into here. So I've shifted it over, and then I need to shift it down one or something. What's the answer? What's the logic to get diagonals going? I'm very tempted to look at my solution to the Xmas. But this is what learning is. Just slow, painful. Wow, what is a diagonal in this case? If I rotate this 90 degrees and have 0 here and drop it and drop, yeah, it has to be dropped both times or something. You know what? This isn't quite cheating. I'm going to look up in the bacon crate. Bacon crate. Oh, flashbang. Sorry about that. Diagonal. Reflect diagonally. Yeah, well, okay, here, if I do diag, r log, AOG, right? And let's clear this out. Scroll back up. And let's exit here. I'm just using arbitrary numbers, diagonals. Yeah, that maybe that's reflecting diagonally, but that's not what I was thinking. Main diagonal of matrix. This is going to be a bunch of ones everywhere, but let's try it. Let's just see what this does. Let's explore. Oh, that's just telling me what the actual diagonal is. Wonder how come. Yeah, well, I can look it up, I guess. Reorder the axes. Yeah, don't know. Have to think about that another time. The diagonal matrix of size J1. J is a number, so a list of numbers. And M and N are just numbers again, yeah. So a list of size some number list shaped in that, I guess. Oh, is this what I'm talking about? Zero 057 is 057. Is that what I intended to do? Skew Y2 to turn diagonals into columns. Oh, I don't want to wrap around either. But it did the same thing I was talking about, sort of, where they're coming from the right side. So what used to be on the right side is now in the middle, and then what used to be on the very right side again on the second row is pushed in all the way. And my solution was just going to put zeros here or dots, but they're keeping the old value from the left side. But it doesn't give me my 0 here to the 4 spot. Do I just have to drop one and repeat it? So if I get rid of this bowl hockey and put this back, right? Transpose it maybe? And then I would, yeah, do the same thing where I do the under drop. Let's see. Or shift, sorry. This guy. And then I would I don't think this is right anymore, but I would drop the last column. No, that just gives me. I want to get dots now at the top of the thing, which would make sense actually. I would now here calculate the length of the first cell, which is 3, and I would repeat that. I would repeat this that many times. Is that right? This is supposed to be a function. Uh, still not a function. Let's get x in here again, and then say, hey, we're repeating this. OG, oh no, OG diagonal, good. Now I want to join this with this. Yeah, there you go. Is that a diagonal? So because you don't have any upper lefts, nor do you. Your upper lefts are not displayed. But 3, 4, and 5 have this guy has no upper left. This guy has 0 as the upper left. This guy has 3 as upper left. Okay, that's something good. Okay, then again, I'm just going through my list of F's here. Let's get rid of this the cheap rotations that I did. So this is the same as before, and so now the second F I would take is here, and I would change this to rotated. Then I do this here, and what is this saying? This is the bottom left is 6, and then the bottom. No, that's not right. Two? No, these aren't. This doesn't look right. It still doesn't look right because I'm expecting uh some number to be 2, but this number shouldn't stay 5. Oh goodness! And then this join shouldn't be at the top anyway. So I gotta figure out a better way for that. Yeah, I'm just. Do I have to like rotate it again or something? I can going by feel here rather than anything else. How does this make sense? 7 and 6. Uh, no, yeah, because this is crisscross. 6 and 7 and 3 and 7 and 3. That doesn't. That's not what I want. No, something's weird. Something. Okay, if my original answer, sorry, was this, I think I see what I did wrong there, but this is my original diagonals. So now I want to flip this, like I said, here, here, and here, and then here, but I want to undo this or something, right? Well, that actually kind of looks right, sort of. So 6 is your bottom left, and here's bottom left is 4, and 3's bottom left is nothing. Okay, okay, we're partying again. So it is the same. So if I want to do the next one, then we'll figure out together what it is. If we do A after this, which is transpose, and then here put a nothing, Oh, come on. That didn't look like it changed anything. Because this thing, I have the first thing I'm doing is rotating, and then I added a transpose in front of it. So when I did this, why is it not simply changing? Why did that appear to have no effect? Because no, I don't know. If I get rid of this here and then this here, no effect, right? Yeah, no effect at all. Okay, here F is this. Transpose, cell, yeah, rotate. Right, we could do this. This is what we want. And then now if I do just here is being identity because it won't matter. This is now the top left. Can I just do the same thing? No. No. What do you mean reverse not phantom? Okay. This is now top left. Just doing stuff at random here. But this isn't. Okay. Where is this one? I don't understand how this is working. Did I break it maybe? Is that why I'm confused? Dropped left. Dropped right. Yeah. Dropped top, drop bottom. Yeah, this looks good. But I'm not doing that, I guess. Here. How did I how did I get it to have the right answer? Lost in the sauce. Here. Good. Here. Top right. But I want the bottom right now. No. 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 Come on. Surely there's a way I could just get this going randomly with luck. The longer these sessions go on, the more we just give her sometimes. Eventually you'll get it. So what this is doing again is going for every row and then turning to 201 543 866. Then it's transposing it and transposing a list. What does transposing a list do? Uh, Exit, show, ABC, right? We know what reversing does, right? It'll turn to CBA. But transposing it does nothing. So it's specifically only when you have like a list of DEF, yeah. Not even a list, a matrix. So ABC, DEF turns into like yeah, vertical or whatever. So for every row, invert it. But this is already what it's doing. It's not. Hmm. And if I do this again, it'll be this this. Is it going to be that I have to choose whether it is a left or a right switch? Like a shift, I mean? So if I change this to the other side, it'll be a different answer. Is that the trick? I don't like that if that's true. Again, to simplify this, we can do, I think, all of this. Under, under, under. Yeah, just to simplify our lives a little bit. So get rid of this. The length of list of W must be at most rank. Well, given that I know I have to I have to like I can do this. Oops. Yeah, two here. These guys this. And then actually I can do this too, right? Or no, it's the same answer. Surely this is a different answer. No? Okay. So this or this. Wait. How do I get the bottom one at one point? The bottom right. Top left. Bottom right. Bottom right. Top left. Okay, I guess I just thought I had something else. Okay, I'm gonna change this to a friggin' function so I don't have to think about this anymore. What? What? No undo header for this block. Surely you can, oh, because it's a function, it doesn't have an automatic doesn't have an automatic way of doing it, so, but that's why this would have to be this. That's irritating. I get it, but damn, dude. Top left, bottom right, top left, bottom right. Oh, is this even? But I need the diagonals in there. So this is top left again. This is just bottom left again. So top left, bottom left. I really think if I do some sort of transposition again, it should be fine, but this is bottom right this time. Okay, bottom left, 3 and 4. Or sorry, 6 and 7. So this is yeah, bottom left. Then put this back. This is top left. This is required for bottom right. Top right. Top left. Bottom left. Who knows, man? I just got stuck in a cycle there for a bit. Yeah, okay, so I can combo all these together, I think. Here, here, here. No, fudge. Why don't I do these things again? This looks a whole lot like this, actually, but that's fine. Whatever. We can deal with this as we go. So here, here, OG here, and F. I call it B's for bars instead, for food bars. B's. Okay, so we have rotate on its own. Then we have this. Okay, so we should have, if we see two diags, good. Now make a new one, and it's gonna be this with a rotation after. 4, 5, 8, and 7 is the top right. So this looks correct. Which is the one we're missing? Is 2 rotates the same thing? Okay. So let's put these together. You know how fast this is going to come if it comes out? No, I lost the order here. I want top left being first. So here being first. Let's see if I can. Oops. Delete. Find this. Yeah. How come that's? The second function is what I want. Yeah. So here. Oh, I see what's problem. Okay, so this is what I wanted to do. Okay, top left, bottom left, top right, and then 2x and paste. Oh, okay, good. Okay, so we have our functions to get diagonals. I'm not making it. This is just, I was all field. I wasn't at all, as you can tell, understanding the problem. That's why I don't like puzzle games, because that's all I do when I try to solve puzzles. So this is all the diagonals. Okay. So I'll call this df's, okay, for diagonal functions. And then just call them d's for diagonals, I guess, right? So if I want to show every d's, yeah, that's good. That's what I want. Okay. I didn't print this file. And then I have to do the same thing for f's, where it's instead of f's, it's nfs for neighboring functions, ordinal functions, uh, or, ordinal functions, ordinal functions. Yeah. Oops. Sometimes you gotta try to get fancy. Okay, and now this is O's for ordinals. Okay, and again we can do this. I I bet you. I was gonna say, I bet you that this shape would look a lot like these guys or something. And there's a way I can, like, reuse the same thing because it's pretty, you know, similar. But let's get rid of the logs here. We're worried about we're moving past logs. And we want to go. Well, no, we're not at all past logs. Here, these. And this has to have a left organ. Perfect. And then O's. Thank you, Copilot. Okay. So top left, top right. Sorry, top left, top right. 8 is bottom right. This is bottom left. Okay. Now O's. I can't keep track of two things at once here. This is left. Good. Now I want 5 as the next one. 5. Good. Then I want 7 as the last one. Oh, 1, because I forgot the top. Sure. So O's is left, then right, then top, and then down. Is down here 7? Okay, good. So now, okay, these are all. I'm gonna drink some water. Hold on. But these are all the. These are all the neighbors. Very easy to read. It's been an hour and a half. If I use instead of OG, if I call OG okay, I'll do the same thing actually, but I'll just write lines. No, I just want that to work so bad. Oh, here. Okay. Okay. So I have to stack them on top of each other or something. I have to I have to like compare all these things together. How do you compare like 100 things in the sample? And actually, this is even larger in the real thing, isn't it? Inputs. Oh, we're on day 4 now. How wide is this? 137 by 137? Okay, good. It'll be nice and fast. Well, that's the nice part, is that this will actually be really fast, but I don't know how to do it. Is it just a fold? Okay, if I go back to here, and then I combine D's and OS, right? Show. Okay. Then I fold over them and I say here, right? It should give me a single answer. And the only time that they're all the same, right? Yes, awesome. The only time they're all the same is when it rotates, because it's rotating on the middle. Maybe no, that's not right. That's not right, because at no point does the center not change. So I take that back. False alarm. Can I show shape? Yes, a element list. That's just like I think. I think I want. So when I did this, what? How come? Right, because it's not like accumulating so much as like it's actually yeah, it's just passing along. It's passing along this array, and then it's saying, "Hey, is this number equal to this number?" And you'll say yes, and it just toggles back and forth. I bet. Okay, that's not the right answer. So I can do something like equals dot or something. Equals dot, maybe. And then sum, does that work? Okay. Okay. All right. So we're plowing ahead. There's a little bit of time for reading later. No, I take it back. That was too greedy. Because how come? How come here? Okay, hold on. Okay, hold on. Less than three. Uh, less than three. No. Uh, greater or less than three. Okay, hold on. Look at this. The sample. uh, no, that's not correct. I wanted x's everywhere. X is here, but it's because we're having um matches or something here. Oh, in the OG, yeah, in the O. Oh. Do I have to just join OG to this? Maybe OG, and then enlist this, enlist this, enlist this. That's even worse. Okay, my logic is not quite there. Because this was supposed to count. What OGs are is its neighbor shifted a certain way, right? And we want to see if any of its neighbors. Okay, here. Okay, let's try this out. Hold on. Equals OG, right? Here, hold on. We have this. These are all the ats in the original, right? Good. So now I just times it. Okay, and then these are uh, uh x is greater or equal to 3. Okay. No, I'm still wrong. I'm still wrong because this is there's I'm looking at these two numbers here, right? This is good. There's a gap of 1 space and then 4 x's. Oh, gap of 1 space and 4 x's. Now we're partying. Okay. Is that right? Next row. 3 ats or 3 x's and a space. Oh, yeah, okay. So this is what I'm wrong with. I was wrong with. Hold the front door. These aren't x's. These are all the at symbols. So how come this is doing nothing? And then which one of you are 3 is greater than 4 is greater than this number? Just feeling her out here. This is look more like it. Yeah, okay, this this is it. Was my logic just wrong? Oh, because it was, instead of this, it was, uh, if I rotate this, I should get the exact same answer, right? Yeah, okay. And so I just had my operator wrong, I think, where it was this. Yeah. If I go back in time, you just see, yeah, greater or equal to 3, but I want less than 4, right? Fewer than 4, less than 4. Okay. Okay, we're totaling. Good. I'm happy we explained all this. So count the number of things. So you just have to do this or something, right? This? No. This. What are you talking about? What are you talking about? I want to D-shape this. Good. And I want to sum it. This should be 13. Great. Great. Solve day 4, part 1 sample. Okay, we're going to return this. Great. And we're going to get rid of all these logs. We're not even going to worry about it. We're not even going to worry about it. We're just going to go here. 13. Good. Now we do lines. 14, 40, 14, 6, or whatever. Easy. Barely any time at all. Okay. Let's go our expectations at the bottom here. Expect, oops, expect 13, and I think it's like 4, okay, right here. Nope, 14, 16. That would have been a pain to, oh, this is my screen, 14, 16, perfect. Okay, good, good, good. Let's see what part 2 is. Now, it can be removed. Once a roll of paper is removed, the forklift will be able to move more, which this is also familiar to something else. Which do I be able to remove? How many total rolls of paper could the elves remove if they keep repeating this process? Starting with the same examples above, here's one way you could remove as many rolls of paper using highlighted at symbols to indicate that a roll of paper is about to be removed. Once the paper has been accessed by a forklift, it can be removed. Okay. Oh. Oh, okay. Okay, that's not so bad. So, it's basically that's why I use X in the first part. So once the X is removed, then I would just replace this. I'd replace all the X's with periods, and it would just keep going. Okay, that's definitely doable. I, less than 10 minutes. Hopefully less than even that. Okay, so let's go here. Part one. I'm gonna copy and paste all this. Let's just do it without even testing it. Okay. Part 2 sample should be 43. 43. That's okay. So now we're going to go here. Part 2. We're going to get rid of all the prints. That's how confident we are. Except for the last one. Oh, what was the total? Oh, yeah. Okay. It's shoot. Okay. So I need to count these totals. But this, we're getting our log back. So this is our mask, right? This is now our new mask. It's called M. Where we want to now replace all these M's with in the original, in the OG, with a dot. Let's get rid of this. Okay, let's get rid of this again. Come on, 8 \8. There we are. So I want to take my OG, right, which we can see here, which we show it, and I want to say under mask. Let's just return. Let's say a dash or something, just to have a just to have something fun. Is how it goes? I? Is this the right answer? No. Part 2 is wrong? What? Is it this? No. How do I get? Well, I can just flatten it, I guess. Yeah, there you go. So then I replace them with periods. And this should look more like what the step 2 is after this thing is. So it's the X is here. So there's 1 on the first line and 3 on the second one. Okay, let's look at the remaining trees. 1 on the first line and 6 on the second line. Yeah, this is it. 1 on the first line and 6 on the second line. So this is kind of how we do it. We gotta iterate it over and over and over again. Okay. Uh, so I want to pass OG in as the board or whatever, right? Okay, so board equals OG for now. Board, board, and then from the output here, we want to say we want to reassign board to this and calculate mask. And what is the stop condition? Once, oh man, oh it's gonna be a while loop. Oh man, I don't remember how whiles work in BQN, so this will take longer than 5 minutes. It's 1:46. Um, okay, let's just do it. Let's just go whole hog here. But the idea is board is a global state, but like our new f function here is doing this, right? And then it's gonna let's just say x because we'll need to do this, right? So it'll return some total uh based on our part 1 here, which is the mask. Like we're returning the mask plus some fold this of m, right? This is our score for this iteration, and we want to just start with OG f, or we got to run f a bunch on OG while the result of f is not 0, and also accumulate the total or something. Uh, say score, okay, and then return score, and we want to score the total, I guess, an empty list, okay, and then we want to say scores join score or something. Does that work? So we append scores. This is awful. Part 2, yeah, part 2, good. And let's say this. So we get 13, yeah, but we want to. All right, let's look up the spec functions. Not fold, not try, not under. It'll be a system function, but it's kind of hard to find system functions. Okay, good, found it. While it's right there. Run f. Shoot, how does if you have this F and G, F is the first one. So run F as long as G, the condition, returns 1. Good. So the to modifier, so this takes two functions, F and G, and runs W and V, which I assume is V is the rightmost value, uh, which is initially X. Uh, so how do I set this up so it doesn't fail immediately? G becomes find moves or check score. Okay, let's do that. So I guess here cond for condition is I would love to have this be a state, but yeah, let's just do this. And then return the sum of whatever. The plus fold of m. This is condition. Does it care if it's 1? Or this causes an error, okay. Okay, does not equal 0. 0 does not equal this, okay? So that's the condition. Now F is what? How does F work? F takes the V again. Okay. If 0 returns V, if it's 1, updates V to the result of F on V and starts again. Yeah, good. I'm not going to be able to read that. That's a lot of characters. So, let's get to the score check. Okay, M for score. And then M is score. Oops. Then what? Who cares what F returns, right? Updates. Oh. Okay, so I I hate to have global state again. But we got to. Why is this score? This should be OG, no? M mask. Oh shoot. Cond. What is V again? Repeatedly G of V. Yeah, so the condition needs to take uh the board. It takes the board. Okay, so this instead takes board. Okay, and then here let's go while F cond. Okay. This takes the board. Right. This takes the board. All G does is return the score. So if condition is true, look how hard this is for me to follow, man. If a condition is true, then it just passes V to F. Yeah. So calculate the board. And this is still board here, actually. And we want to actually gosh darn it, we want to actually just return fuck. Shoot, I mean. Here. Let's I want to because this is a valid loop or whatever, I want to take score, calculate it, then I want to update board with the new value. OG being board. Oh shoot. I have to do all this. Is this right? Cond. R log. Cond is 0. Score does not equal 0. Score is greater than 0. Okay. Now we want to return scores. Because we set the scores to this. uh, scores is here. Here, it's just keep going. Out is iter. This never gets called. Great. That's because score cond is false. I want OG here. I want board. Board? Don't like this duplication. And then how come? Why? How come this is duplicated twice? Still wrong. Okay, so condition is 0. How come the condition is 0? Condition is 0 because show board. Just to make sure we're on the same page. Yeah. And then this is our mask. Oh, greater is fuck. Shoot. Okay, that's good. Con is true. Then we're inside F or iter or whatever. So now what is this doing down here? What is show board? What does this do? Come on, man. Sprint a few times. Okay, board is what I expect. Right? Because board is given condition is saying, hey, is the score valid or greater than 1? And F here, iter, if you would, iter, is iter is once again checking the score, updating the score, then looping. And it's complaining that at some point in here, when I'm rotating it, you can't see it, but that's what X is, I guess. I show X, it won't actually work, right? But it should though, right? X cannot be a unit. Put another show. We should have another. Wait, you're running somewhere else. This is condition, isn't it? 46. Show board. 13. So I don't want to kick scores here. I want to update board to the, wherever I said that they're not, show and then exit. What do we got here? The under thing, right? I did under somewhere, or did I get rid of that? Not under there, not there, not there. I must have deleted it. Darn it. That would have been nice to keep around. Okay, so, yeah, what? Are these all the valid removals? To the space. Yeah, okay, so these are all the places where I want to under and flatten and stuff. So okay, that's well, this is still M, right? This is still M. Yeah, M. Okay, so then I want to flatten it. I want to right. I want to under. Uh, just make sure I'm on you here, and we're gonna do this. No. Expected integer got character. Board, I think. Inverse does not exist. Really? Lengths. What am I trying to do with this? This is just flattening this, and then here. Okay, good. You're looping forever. That's not great. But you're fast while you're looping, so that's good. Let's not show this. Let's just show score and hopefully get score's always 1. Oh, because I see, I think. Nope. It's looping forever. It's gonna melt my computer. There's like a system that's sleep or delay or something. Delay? Yeah, delay 100. I hate to do it, but it's just working on the same board over and over again. Is that what it's doing? Oh, that's 100 seconds. Man, okay. 0 0.1. 0 0.5. Let's see. It's going. Yeah, it's going with the same thing. So it's as if I'm not. Do I Hugh OG somewhere? No, yeah. So what's the triple? Run F as long as G returns 1. Yes. While runs G, which is a condition, where V is initially X. Yes. So board on condition. The result must be 0 1. And we're seeing here that condition is 1 because there's at least we're seeing the count or whatever. Show. There's at least 1 M in this. If I do this, what's going on here? Oh, cap locks. There's 10 because it's always going to be 10 because I'm not updating board or something. Despite board being the return value. So when I call F, right? F and G, when I call F, update, yeah, exactly. F is the result of board. So can I here exit? I'm trying to see what the I'm trying to see what the output is before and after. Yeah, it was this, wasn't it? Because what I'm thinking is that let's go board again. Our log, right? And this is well, board is not changed here, so we don't have to log it again. Right? So board is this, and then we're updated board. This is interesting. Updated board isn't being updated correctly. What? Okay, that's it. I think that's it now. Uh, okay. So much juice is taken. Let's just get rid of all these logs. So much juice. Show here. Go through the answer in a second. 43. Okay. Solve day 2025, day 4, part 2 sample. Let's change this to this. Here. No. Oh, that took a little while, but 9086. 9086. Hey, there you go. Took almost exactly double. Let's see. I got the message from my yeah. That's good. We had a good time. Let me see if I can clean this up a little bit. Let's get these out of here. We can. It takes forever, man. How come I have to calculate score twice? Oh, sorry. Now I can change the validator to 9086. And then do this. Um, the condition is checking whether any of the mask is true. And I'm checking the mask again. What about last board is board. Okay. Then I say uh, uh, Actually, no. Then I say doesn't matter what this is. I just say yeah, board does not match. Does not match board, and I say I can just do this, right? I can just reassign it and return it. That was really fast. Expected, actual. Oh, because it only loops once. Board does not equal last board. Last board is null. Therefore, that's true. That's gonna loop forever, I assume. So board, yeah, because if this was true, it would stop immediately. I think. Yeah. Because we just want to update. Like run because the thing is still changing. There. Okay, what about res? Here, hold on. Last board equals board. There you go. That wasn't much faster, but at least we solved some a little bit of global state. Takes what, 2 seconds? Do you score anywhere else? Here, surround with this. Nice. And then paste. Change surrounding this to this. Something. Change surrounding this to this. There you go. I'd like to know why it takes so long. Sometimes the notation doesn't make any sense to me. All right. And then I'll just time it real quick to see what the answer is. Timed. Timed. So say, hey, oh, 1.1 seconds is not so bad. 1.11 seconds. 1.10 seconds. Cool. All right. Well, thanks for watching. This is interesting. I learned a little bit about rotations and stuff. We'll have to see if it retain it for next time. Thanks for watching. Bye.